Okay, this is the first part of 17.3, which deals with acid-base titrations. And we have talked about these before. Now we're going to look at them a little more thoroughly with the difference between a strong acid or strong base titration and then a weak acid or a weak base titration. So just to kind of recap from before, acid-base titrations are where you have a known concentration solution and that's added to an unknown concentrated solution. When we talk about a titration curve, that's a plot of the pH versus the volume added in a titration, and that's what we're going to look at a little more in depth here. And that's of the known solution. Okay, the shape of your curve tells the equivalence point, and it also will help you select an appropriate indicator for this particular titration. So now we're going to look at strong acid and strong base titrations a little more closely. Okay, so when a strong base is added to a strong acid, the titration curve looks as follows. And you see there a picture on kind of the right there. We have a strong base being added to something that is a strong acid. And we can see the picture here. Okay, well, you're going to divide the titration curve into 4 regions. And the first one is initially. So this blue right here is my initial. Okay? And what I have circled there in red is my H+, and what I have here in green is the Cl-. So initially, okay, only the acid exists. This is before I have the base being added to it. So I have my little beaker, okay, I have the burette, my stand, I have my burette, okay, and this is going to have the base in it. This is going to have the acid in it. So before I add anything at all, I only have acid. So if I take the pH of this particular solution, it should be less than 7. It should be very acidic. That's all I have. I have just H+ and Cl-. Okay, so initially, for the pH, only the acid exists, and we're going to have a pH that is less than 7. So this is the easy part, okay? If we're dealing with a strong acid or a strong base, then you're just looking at dealing with like the negative log of whatever my H+ concentration is, which would be whatever the concentration of the acid is. So here we're looking at the negative log of just your H+ concentration, which is going to be whatever it is as HCl, okay? Now, between the initial pH and my equivalence point, here's where I'm going to have too much acid in the beaker, and it's not yet all neutralized by my base that I'm adding. My pH is still going to be less than 7. So if you're in between the equivalence point and my initial point, this is that red line here, okay? Notice how it's kind of increasing in pH because I'm going to get more and more basic, but I'm not basic yet or even neutral, okay? So this is going to be this section here, this second box. You have some acid and it's also some base or some Na, okay? So I have too much. My pH is still going to be less than 7. So all I have to do for these is figure out how much excess H+ I have, and however much excess H+ I have, then you're going to do again the negative log. So you're going to have to figure out how much excess acid there is, and then do your negative log of the H+ concentration. Okay, and the third one, now we're at the equivalence point. So now, exactly at the equivalence point for a strong acid and a strong base, okay, so if I had 50 milliliters of acid, notice how 50 milliliters of base is going to equal that out. Okay, at the equivalence point now, my number of moles of base and acid are equal. And in this case, it's going to mean that my milliliters are equal in this particular example. Okay, so my equivalence point is at a pH of 7 because I've got a strong acid and a strong base. I don't have any kind of salt for any kind of weak acid or weak base. All I have right here is just my Na+ and my Cl-. I have salt water, pH of 7. Since only the salt of Na+ and Cl- remains, again, you're not going to make any kind of strong acid or any kind of strong base. Na is not going to do that with water, and the Cl- is not going to do that with water. And notice how I said here, if the molarity is the same, then your volumes are equal as well at the equivalence point. not just the moles of base or acid. Okay, and now after the equivalence point, I have excess base, which means you got to figure out exactly how much extra stuff I have. So now, based on the extra amount of base that you have, I can figure out the pOH and then my pH. And my pH should be greater than 7. Okay, and this is that last part of the curve where you can see here where my base is going to be totally winning. So I've got total excess OH minus, which means that we get really basic right here. So technically the equivalence point is kind of where it's straight. Notice how it's right up there on 50. And then this is all my extra right here where my pH starts to climb. All right, so we're going to look at an example with some math here. Okay, so I'm going to calculate the pH when the following quantities of 0.1 molar NaOH solution is added to 50 milliliters of a 0.1 molar HCl solution. So I know the pH at each one of these points. Okay, now that's going to mean that I have my beaker here that has HCl. I'm going to add different amounts of NaOH. So I'm going to add a certain amount of NaOH to it, which means I'm going to start acidic and end basic, which is what we just looked at. Now you can have ones that are flip-flop of what you see right here, where you can start basic and end acidic, and all they're going to do is look exactly the opposite of this particular graph, and they're going to start up here, have the same equivalence point, and then end. And that's not very good, it should match right there. But you're going to start higher and then end a lot lower. Okay? But this one is just how our example was. Alright, so we can figure out whether it's before the equivalence or after, or whether it's initially. Well, it's not initially, okay, because I don't have any 0 milliliters of HCl. I have added HCl. Well, since my molarities are the same, that means my equivalence point is going to be at 50 milliliters. So this first one, A, is before the equivalence, and the second one, B, is after. All right. So what I need to do is figure out for A, before, what's dictating my pH. Well, if it's before the equivalence point, that means I don't have quite enough base to neutralize my acid, so I should be acidic here. If we talk about after, now I'm going to have excess base because now I've neutralized all 50 milliliters of the acid, and so this one here should hopefully be basic. So let's keep that in mind. Okay, now when I look at A, right, I need to figure out how much H plus and how much OH minus I have to begin with. So I need to know my moles. Okay, so my initial moles of H plus, well, molarity times volume is moles. So my molarity is 0.1. My volume is 50 milliliters, so I gotta change it to liters, so it's 0.05 liters. And I get a H plus to be 5 times 10 to the negative third moles of H plus. Do the same thing for my OH minus. Well, my moles of OH minus, I need to figure out how much extra acid I have. So I got 0.1 is my molarity. I'm adding 0.049 liters, which is going to give me 4.9 times 10 to the negative third moles of OH minus. So how much extra do I have? Well, all you do is you just subtract to see how much excess, see XS, how much excess H plus I have. So I subtract, I'm going to get 1 times 10 to the negative fourth moles of H plus when I subtract those two. Guess how much extra acid I'm going to have? Well, I need a molarity, so I can figure out a pH. Okay? Because it's my H plus concentration, not the moles. So I take my 1 times 10 to the negative fourth moles divided by the whole liters. Well, it's the two added together because that's how big my solution is here in the beaker. So I add 0.05 and 0.049, which is going to be 0.099 liters, which is 1 times 10 to the negative third molar. So I do negative log of 1 times 10 to the negative third because that's my molarity of my H plus. That's left over. It's going to give me a pH of 3, which totally makes sense because we are acidic. So do the same thing with after, but flipped, because now I will have extra base. So figure out how many moles of H plus, how many moles of OH minus, subtract the difference, divide by your total volume, do the negative log. In this case, though, this is my OH minus concentration because I have extra base. So I knew the negative log of 1 times 10 to the negative third. And now I'm looking at a pOH of 3, which means that my pH is 14 minus that, so my pH is 11. And we are basic. Okay, the last thing is indicators in pH. Okay, color changes very rapidly at my equivalence point, so you got to make sure that you have the right indicator. Okay, and you need an indicator that changes color over the rapid rise section is the best kind of indicator that you can have. So if we look back at the strong acid, strong base picture, notice here that phenolphthalein changes between 8 and 10. So that's why that's a very good indicator, because I can tell very quickly where it is, where it turns basic. You can also use methyl red, but that's probably not as good because it's changing at 6. So you kind of have one that'll go from red to orange, or one that goes from kind of clear to purple or pink. So the pink one is a little bit easier to see.